Hello everyone, welcome back to another video of Data Science Basic to Advanced playlist. In this video, we will be discussing about dimension reduction. So let us first understand the concept of dimension reduction. So dimension reduction is the process of reducing the number of features, i.e. dimensions, in a data set to improve model performance, reduce complexity and eliminate redundancy. Involves techniques like multicollinearity analysis and principal component analysis, that is PCA. Now, identifying multicollinearity. Multicollinearity occurs when two or more independent variables are highly correlated with each other. This can cause problems in regression analysis because it becomes difficult to determine the individual effect of each variable on the dependent variable. To identify this, we use correlation metrics, that is high correlation between the variables suggests multicollinearity. Variance inflation factor VIF. This is quantifies it quantifies how much a variable is inflating the standard error due to multicollinearity. So let us understand the Python code for the same. In this code, we are first we are importing necessary libraries like pandas, numpy, fetch, California housing to give data sets, and variance inflation factor, and the last library is add constant. In step 1, we are loading the data set, and in another step, we are adding the constant features of VIF calculations. In third step, we are calculating various inflation factor VIF for each feature. And now in the last step, we are printing the value of VIF. Let us run this code. Here is the output of this code, which is giving features and the values of the features, which is VIF. So, in this example, VIF calculation for each feature, VIF is calculated to detect multicollinearity. A VIF value greater than 5 to 10 indicates high collinearity. In this example, only the consts have high multicollinearity. Add constant. We add a constant to the data include to an intercept in the model. Also output. The VIF values are printed for each feature. Features with high VIF values greater than 5 or 10 should be further investigated for removal or transformation. Now, let us understand PCA. So PCA is a technique for reducing the dimensionality of the dataset by transforming the original features into a smaller set of correlated variables, principal components that capture most of the variance in the data. Here is a Python code that demonstrate the use of PCA. Here we are importing some libraries. We are importing PCA standard scalar, PLT, uh, Matplot library, and NumPy. So in first step, we are loading the California dataset. In second step, we are standardizing the features. In third step, we are applying PCA. And the fourth, uh, we are explain variance ratio. In fifth step, we are plotting the explained variance ratio. Then accumulating the output and then applying PCA with the chosen number of components. In last step, we are plotting the first two principal components. Let us run this code. PCA is sensitive to the scale of the data, so we standardize the features using standard scalar. So in this output, the explained variance ratio tells us how much of the data's variance is captured by each principal component. Now, let us get to the conclusion that multicollinearity detection, we used the variance inflation factor VIF to identify and quantify the collinearity in the dataset. Features with high VIF values should be considered for removal or transformation. A principal component PCA was applied to reduce the dimensionality of the dataset while retaining most of the variance. We visualized the cumulative explained variance to decide how many components to retain. By combining both the techniques, we can reduce the complexity of the dataset and improve the performance of machine learning models, especially when dealing with high dimensional data. This is all. This is all for the video. Thank you for watching.